Hello and welcome. I will be out for the next 2 weeks due to some family issues. So all of your lessons will be virtual for the next 2 weeks. Now, if you're a seventh grader, then you have already done part one of this. We did it in class together last week. If you're an eighth grader, you need to make sure that you do part one first before moving on to part two. This is part two where we start talking about having our microbit encrypt messages for us. Okay, this is part two. There is a PowerPoint that goes along with it. This PowerPoint is located within this Google Classroom activity, so you can follow along with this PowerPoint, or you can watch the video with me as we continue through this. Okay, so first of all, what we're going to be learning about is encrypting and decrypting information. So encrypting means the process of encoding information to make it unintelligible, which means to make it difficult for you to understand. And decrypting means the process of taking that unintelligible information and make it intelligible again. So basically, take a message in English, code it into a different language so you don't know what it says or other people doesn't know what it says, and then you can decrypt it back to English so that you can break the code. Encrypting is using to send sensitive data safely across channels that could be monitored by malicious users. So if you'll notice right here up at the top, there is a lock symbol next to my HTTPS address here. And that means that all the information on this page is encrypted. None of the information is going to be given away. Now, there are sites I can go to. Let's see. Not that one. Let's go to Pandora. Pandora is encrypted too. Green Acres website, Green Acres encrypted. It's most likely all encrypted because I am on Green Acres Wi-Fi. If you're at home, you might notice that lock disappears. But that lock should be there before you ever put in your credit card information. So if you go on to eBay or Amazon or Facebook, most likely that encrypted thing might not be there until you log into your account, and then that encrypted thing would show up. And then if you're entering your credit card information, it's really going to encrypt the information, because if it doesn't encrypt the information, then it's going to make it so that other people can easily steal it. Okay. So what we're going to be doing today is we're going to first of all set up our microbit to where it can do the alphabet for us. And then after that, set it up to where it will start encrypting the alphabet so that we can send secret messages. Okay, so you should have your computer, your download cord, and your microbit. You should have all three of those things. I have mine. So let's get started. Now, by the end of this lesson, you'll be able to write Python scripts that make your microbit receive, process, and respond to text numeric values you type into a terminal app, kind of like what we did in the last lesson where we'd ask our terminal a question and then it would respond to our question. And along the way, you'll build basic skills for tutorials on these topics: simple attacks and radio encryption. Okay, so encrypting letters by hand. So I'm going to move this here. We saw an example of a Caesar cipher, especially you saw it if you were with me in the past couple of years. We've done Caesar ciphers. We did the Caesar cipher wheel. We were able to take a message and really encrypt it. So if we do a hello with a shift of 5, that means A is now 5, or we move everything 5 letters over. So 1, 2, 3, 4, 5. And we want to do hello. Okay, so H, if you count 5 letters from H, that becomes an M. Then we do E, and if I count 5 letters, 1, 2, 3, 4, 5, that's now a J. L is 1, 2, 3, 4, 5, a Q. And then O is 1, 2, 3, 4, 5, a T. So hello encrypted with a shift of 5 would be MJQQT. Now, if I just put MJQQT on the board, you probably would not be able to understand it. That means it's been encrypted. It's unintelligible. Now, you could probably work and figure it out. So Caesar ciphers are not completely foolproof, but it does take information and encrypts it to make it a little bit more difficult to understand. If we wanted to go backwards and we know it's a shift of 5, that means you subtract 5. So M minus 5 would be H, J minus 5 would be E, Q minus 5 would be L, and T minus 5 would be O, and we get the message hello again. Okay, so what happens if you're about to encrypt 5 spaces with X? So obviously X is located towards the end of the alphabet. Basically what happens is just skips to the front. So 1, 2, 3, 4, 5. So X plus 5 would be C. Z plus 5 would be D. W plus 5, 1, 2, 3, 4, 5 would be B. Okay, so it just goes around the alphabet again. Okay, so I could tell you, okay, pick any word you want, do a plus whatever number you want, and you should be able to take a word and encrypt it as a Caesar cipher. Now, of course, it does take a little bit of time because you have to usually write out the alphabet, do plus fives, do minus, blah, 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 blah. And then when you want to decrypt it, you have to do the subtraction, and it takes a while. Of course, we're in the 21st century here. We want it to go faster, so we're going to do it automatically, and we're going to do it with our microbit. Okay, so we're going to have our microbit in our computer do all the steps for us by going through our terminal. There it is. Okay, so what we want our microbit to do is store the key in a variable. So whatever, if I want to do plus 5, 7, 10, 12, 25, whatever, it will store that in my program. Then it will take the message that I'm take that, turn it into a variable, find the index of the plain text letter in the alphabet, and add the key to the index and find the store the ciphertext of the new program. Okay, so here is the program that we are about to do in our microbit terminal. So I'm going to go to the Green Acres website. I'm going to scroll all the way down, and I'm right here within my microbit terminal. So actually, this is not the microbit terminal. This is where we program. I want to go right here to serial. So when I click serial, it wants me to pair, connect, and boom, now I am in my terminal. Now remember, if at any point I am going too fast, pause the video and catch up. If you need to rewind, then rewind the video. If you need to kind of go back to the beginning because you don't understand something, that's why this is a YouTube video. Do what you need to do, okay? So the very first line we're going to do is we're going to do from, I'm going to click that right there. I'm going to click that. Okay. I'm going to highlight all this. I'm going to keep from microbit import, and I'm going to do sleep 1000 alpha, which means I'm taking the word alpha and making it a variable. And I'm going to do the alphabet. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay? So if you don't know the alphabet, that might take you a second. So pause the video and catch up on the alphabet. And then I'm going to do letter equals M. And sorry, that should be a lowercase l. And then I'm going to do index equal alpha dot find letter. And then I want it to print, which means I want it to display in the terminal the letter that I entered, comma, letter, comma, index, index equals index. Okay? So I'm going to flash this. Good. I don't get any line. I get a line error. line 6. Okay, why does it not like line 6? Oh, I forgot to put quotation marks here. That is why. Okay. Okay, so now I'm going to try that again. Again, the best part of programming is finding your mistakes. Okay, no line error. Open my serial. Index equals 12. Okay, so now if I want to do, okay, 3. Okay, so where is the letter 3? 3 is -1. Okay, so this shows how to create a string that is the alphabet, and how to use the find command to find and locate the index number of a certain character. So that's the wrong thing. That's what I'm looking for. The script that does the Caesar cipher has to start by finding a character in the alphabet. The following is an example of a script that creates the alphabet string and finds the index number of a certain character. Okay, so verify the terminal shows the letter M with an index of 12, which it did. So if I go back here, thank you, and I did a 3. That's why I went E. Why did I do 3? I don't know. 3 is -1. Okay. Let's do M. Let's make sure it checks. M gives me, now I went to flash. M gives me 12. Okay, so what that means is I verify the terminal letter equals M is an index of 12. Okay, so find a character, how it works. The script finds a character in the alphabet. This script creates a string that contains the whole alphabet. Okay, when it uses the string.find method, okay, to get the index of the character. For example, if a string with the alphabet is named alpha, then alpha.find M should return 12, and that is because M is the 12th letter in the alphabet. Okay, so what number do you get for the letter A? So if I go here, I do A. Let's hope this works. Open serial. A should be 0. Awesome. Because if I go back and I look here, A is 0. The index always starts with 0 because that's the first value. Okay. Let's do C. So I'm going to close my serial. I'm going to say, okay, where is C? And C is 2. Let me go and check. Yes, C should be 2. Okay, it's the third letter in the alphabet, but starting with 0, it is spot 2. If I want to do P, if I want to find my P, I would look in the toilet. Okay. P, flash, open serial. P is equal to 15. Let me go check. Yes, P is equal to 15. So I am doing, my program is working how I expect it to work. If I do Z, sorry, I'm in the building by myself and I just heard a noise. I'm going to flash this, open my serial. Z is equal to 25. Sure enough, Z is equal to 25. So my program is working, okay? So sure enough, I got those same numbers. Now what we're going to do is we are going to encrypt a single letter. So the following script encrypts a single letter with the script cipher. We're going to enter and save and flash this script. So you can use the PowerPoint or you can work along with me. In fact, I didn't want to do that. So sleep 1000, that's going to stay there. Then I'm going to do key equals 5. So that's plus 5. Okay. Letter equals M. I'm going to get rid of this letter because I just put the letter equals M. I keep my alphabet there. And now I'm going to keep index find letter, print letter equals index equals and do index equals index plus key. Okay, so I've taken my index value, so 0 through 25. I've added it to my key. So here my key is 5. And then I'm going to index equals index percentage. Or is that above the 5? 26. So what percentage of 26? And then the result, which is a new variable, is going to equal the alpha value. Now I'm doing brackets, not parentheses. So brackets are the bottom thing next to the P. Index, close brackets. Print, open parentheses. What is my new index? So my original index is what value? So A would be 0, Z would be 25. Now I've added my key to it, so I'm moving everything over 5. So my new index will equal index, comma, quotation marks, comma, result equal quotation marks, comma, result, close parentheses. And then just because I like to do this, I'm going to put pause, sorry, not pause, sleep 5,000. So it's going to give a second before all those extra fun words come up. Okay. So before I run this program, I took M. I did a shift or a key shift of 5. So 1, 2, 3, 4, 5, which means M should come out as R. M should come out as R. So let me flash it. And it looks like I have a line error. Woohoo! Line 13, okay? I messed up on line 13. I am not surprised. Why doesn't it like that? Okay, does it not like that I put this sleep 500 in there? Let's see. Nope, still having an issue. Line 13. Ah, there's supposed to be a comma right there. Ha ha. Let's see. Okay, no more line error. So I'm going to put that sleep back in there. Sleep 5,000. I'm going to flash it again with that 5,000. Over 5,000. And I'm going to open my serial. So M equals 12. My new index is 17, which is the letter R, okay, which is exactly what I predicted for it to do. So if I go back here, okay, what is the letter V plus 5? So that'd be 1, 2, 3, 4, 5. That should come back as an A. Should. Let's see. Open serial. Yay, it came back as an A. Its new index value is 0, which gives me the value of A. Okay. Oops, I clicked the wrong thing. Sorry about that. I want to close my serial. I want to go back to my program here. Yes, I know the microbit is there. What if I did the letter, okay, let's do the letter H, but let's do a cipher of 9. Okay, so that'd be H, that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, which means I should get the letter Q. So let me flash that. Open serial. Yay, I get the letter Q, the new index value. So that'd be 7 plus 9, which would be 16. give me the value of Q. So far, my program should be working. You should be doing this program with me, okay? Remember, at any point, you can pause the video and catch back up with me. Okay, so we did that. We did a single letter. Fun times. We encrypted. Now we can decrypt a single letter. So instead of doing 5, I can now set it to -5. Okay, so if I want to say, okay, -5 S. Okay, so it's going to go S. It's going to go backwards 5. And that'd be N. So NOPQRS. Okay, good. Let's say I wanted to find, okay, -9 from the letter V. Flash, open serial, it's the letter M. Okay, so if I add, it's encrypting. If I subtract, it's decrypting. Okay, so we're good so far. So our program is continuing to do what we want it to do. Yep, just showed all that. I'm cool like that. So we know how it encrypts a single letter. It takes that key, takes the letter, which is M, finds M in the alphabet. Decrypt it, works the opposite direction. All right, your turn. Set up a ROT -13 cipher. Is a cipher where the shift is 13. You're going to test it with the plain text hello. Okay. So if I want to spell out the word hello, okay, so I'm going to go here to my program. I'm going to set it to 13. First letter of hello is H. So I'm going to do open. Oop, I forgot to flash it. Okay. Open serial. I get U. I'm going to go back here. Next letter is E. Flash it. Open serial. I get R. Close my serial. I'm going to do L. Flash it. Open serial. I confused it. There we go. Y. I'm going to close my serial, and the last letter is O. O. Okay. Flash it. Open serial, and that's D. So hello encrypted with the +13 is URYYB. Okay. Now, before somebody asks, let's say instead of doing a capital O, I did a lowercase o. Sorry, a lowercase o. If I flash that, okay, if I come over here to open my serial, okay, it's not quite understanding what I'm doing because it is negative. It's kind of confused because it's a lowercase, blah, 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 blah. Okay, try to keep it capitalized because that's what our variables are right here. They're all capitalized. So, sorry, something doesn't seem to be working. There we go. Okay, so encrypt and decrypt the terminal. So what we want it to do is we want it to do a loop so I don't constantly have to be going back and forth, back and forth, back and forth. We want it to be able to, I can stay inside the terminal, click the keys that I want to, and go back and just stay inside the terminal, okay? So Right after the sleep 1000, I'm going to add the while true with a capital T. And this is going to be text equals input, enter key colon space in quotation marks in close parentheses. So it's going to ask me to enter my key. So I can do plus or minus whatever number. Okay. Then key is equal to whatever text that I entered. Okay. And then the letter, now it's going to ask me, okay, what letter do you want me to encrypt with that key? So letter, enter a letter. Okay. And the letter is going to be the letter dot upper. Okay, so the uppercase version, it's going to automatically make it. And then I'm going to take this alpha right here. I'm going to put it right there. That's why I was kind of keeping all this stuff because I knew I was going to need it in a second. And then I need this index. Index equals alpha dot find letter. Okay. And then index equals index plus key, so I don't need this. Okay. I do need the index. I don't want it to display all that. Well, you entered this, blah, 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 blah. Okay. And then I want result equals alpha index. And then all I want it to do is print result equals comma result. So I'm going to line this up, and then I want it to sleep for 5 seconds. Okay. Woo! So with this program, I should be able to enter inside the terminal, enter an alphabetical letter, A, B, C, D, all the way to Z, and then hit enter, and then it's going to ask, enter a key. It's going to ask me for a number. Then I'm going to ask me for a letter, and then it's going to tell me what that is. So let's flash this to my Microbit. Open serial. Okay, enter key. Okay, I want to do 5. Enter 11, a letter M, and that's R. We knew that. Okay. So there we go. Now it's asking us because it waited 5 seconds. I probably want to get rid of that 5 seconds now because I'm doing a loop statement. So I'm waiting for that 5 seconds. Downloading it. There we go. There we go. Enter key. Okay, let's do 13. Enter a letter. Let's do D. So 13 or D shifted 13 would be Q. So that means if I do negative 13 Q, I should get D. Okay. Enter key 24 for the letter F, and I get D. I did not know that was going to happen, but it's kind of interesting. I got the same letter twice. Okay. So I can continue with this over and over and over again and do individual letters. So it's a lot faster. If I wanted to do, let's say I wanted to do a new message, I wanted to do, nope, I don't know why. Let's do a shift of 13. So my key will be 13. The first letter is N. Let me scroll down so I can actually see what's going on here. I messed the program up. Okay. I'm going to close material and reopen it. There we go. Okay. So we're doing a shift of 13. Golly, you cannot scare me while I'm recording a video. Coach Parrish just walked in and scared me. Okay. So I have my key is going to be 13. Enter my first letter, which will be N, and the first letter, 13. N, I get the letter A. Okay, 13, O, I get the letter B. Now I can put it in lowercase here because I told it to automatically make it capitalized. 13. Yeah, I messed the idea. I'm going to close my serial, reopen it back up. 13. Enter. I now have to do the letter P. That's C. Shift of 13, and I want to do the letter E. That is R. So nope is, and a shift of 13 is A, B, C, R. Okay, so we have that code. Wonderful. So now, of course, that still takes a little bit too much time. We want to make it a little bit easier, but we now have it to where it will automatically do it within our terminal, and we can check, we can go forwards and backwards to make it work. So if I wanted to do if I want to do a longer message, it does make it kind of difficult. If I want to do the weather is cold with a shift of 7, it's going to take a much longer program because I have to do 7 the T, 7H, 7E, and eventually I will get this message right here. Meet me at the park with a shift of 24. I will do that. I'll get that message. And again, it takes too long because I'm having to do everything individually. So instead of doing one letter at a time, why don't we have it do the whole sentence instead, or the whole word instead? So I'm going to close my serial. And what we're going to do is text is equal to input key. Key is equal to input text. So that's going to stay the same. Instead of letter, we are now doing a word. So enter a word. I'm going to take out letter equals capital. Alpha equals the alphabet. I'm going to do result equals quotation marks, 4-letter in word, colon. And what I just deleted, I'm going to put back. Letter equals letter dot upper. So what it's doing is it's looking at each letter inside that word. It's making it capital. And it's going to do index equals, open parentheses, alpha dot find, open parentheses, letter plus key, money or percentage 26. Okay, so it's kind of taking a couple of steps, combining it into one. Result is going to equal the result plus alpha. I'm going to do bracket index. And then I want it to print result colon. I'm going to do a space, comma, result. Okay, I'm going to delete everything after this. Okay, so now what it's going to do is it's going to ask for a key. Then it's going to take that key and store it. Then it's going to ask for a word. And then it's going to look at that word and it's going to compare it to the alphabet. And then it should take each letter in the word individually. So if I do cake, it would do C, run through all these steps, A, run through all these steps, K, run through all these steps, E, run through all these steps. Now there's no more letters, then it will reprint the result. Now, of course, it does it extremely fast. So I'm going to click flash. I'm going to see if I get a line error. I do not. I'm going to open my serial. Okay, enter a key. Let's do 13. Oops, I got to click there. Let's see if my nope was correct. 13. Enter a word, N-O-P-E. ABCR. Hey, I got it. Okay. We also have 5, a shift of 5 with the word hello. Yeah, that's what we got earlier in the PowerPoint. So now I can decode a whole message. So if I do Richard, oops, sorry, Rich, the key needs to be a number, so 20. And I want to do Richard. So Richard would be LCWBULX with a shift of 20. Okay, so far, so good. Okay. So again, like I said, it waits for you to put the key in, it waits for you to put the word in, and then for each letter, it goes through that, and boom, that is the end. So what I need for you to do to turn in for this video is this program that you have right here. I want you to turn in a picture of this program, and I want you to actually understand how this program works. If you don't understand how this program works, go back and watch the different parts of the video and completely understand how it works. Appreciate Coach Parrish for coming in here and scaring the woohoo out of me. I guess it's just in time for Halloween, huh? Okay, so good luck. Again, if you did not do part 1, please go and do part 1 first. This is part 2. I will see y'all later.